So let's look at this again. So in solving this question, some background, some background. Background 1. Area of a parallelogram. The evolution of area. The evolution of area, if you want to understand it better, you go back to parallelogram. So this is a parallelogram. A parallelogram is a geometric shape. A geometric shape whose opposite signs are parallel and equal. Now, the area of a parallelogram is base times height. But this base and height must be at 90 degrees. The base and height must meet at 90 degrees. From this single definition of area equals base times height, we now ask ourselves, what of a rectangle? See a rectangle here. A rectangle is this one. So this, for this rectangle, this is height and this is base. By the way, what we are calling height, that place can also be base. Where we are calling base can also be height. The most important thing is that those two lines meet at 90 degrees. For rectangles, is already defined. For something to be a rectangle, these angles inside, we have 5 right angle triangles. Remember that to say we meet, two lines meet at perpendicular, simply means that those two lines meet at 90 degrees. Okay, so rectangles are parallelograms and squares are rectangles. So squares are also parallelograms. Then from here, we now move a little. What if we divide this line into two? If we divide it into two, if we draw this line, which is also called the diagonal, we now have half of it. That is where half of it is something like this. You see that half of it is something like this, which is base height. This is because half of something, if the area of something is base times height, so half of it, which is now a triangle, is half base times height. Evolution of this formula.
Okay.
From now on, we are not talking about base and height, base and